Welcome back, students of math. Stretches and compressions, part 1. First of all, what are we even talking about? Let me give you a very simple example, and I'm going to use our favorite function, the square root function. So, actually, let's put a few little tick marks in here. And look at sort of where these key points are. So we know we have 0, 0, 1, 1, and then 4 was up 2. Okay, so this is our original graph. Y equals the square root of x. Now, stretches and compressions. First of all, we're not going to shift the graph. We're not translating it. We're not pushing it left or right, up or down. We're not going to reflect it, okay? It's staying put where it is. But what we are going to do is we're going to take, and I'm going to start off here with the vertical stuff. We're going to take vertical distances, and we're going to make them maybe half as big, okay? That would be a compression. So my first little description here is actually going to be a vertical compression. Vertical compression. All that means is that you're taking vertical distances, like this distance here. Well, and by the way, distances we're talking about are from the x-axis. So it's all relative to the x-axis. Okay, so a vertical distance would be, well, let's see. Here's a point that's up 1. That distance is 1 unit. I want to compress that. So we want to do, let's see, vertical compression by a factor of, and let's keep it really nice and simple here, of 1/2. So I want to make these distances half as big. So this is where I want to be now, half of 1, which is 1/2. If I move along to here, this vertical distance was 2. It's now half as big. Okay, so it's now 1 unit. If I draw in my graph now, there it is, and it's been kind of squished or compressed by a factor of 1/2. Squished or compressed vertically. Okay, now, very similar, what if I wanted to do a vertical expansion? Let's say again, by a factor of, and keep it nice and simple, a factor of 2. What does that even mean? Well, it means my vertical distances, I want to make them twice as big. So this guy used to go up to 1. I want to make it twice as big. It now goes up to 2. And this guy here used to go up to 2. Let's make it twice as big. It now goes up to 4. And of course, this guy had a vertical distance of 0, and so twice 0 is still 0. So there it is. This is my my stretched or expanded version. So now the real question is, I wonder what changes we make to the function that would cause these changes to happen. Yeah, okay, so I'm going to just cut right to the chase, and then I'll convince you that it is true. First of all, we're talking about making vertical changes, okay? So vertical changes have to do with y. So chances are we want to locate the y in our function and make the change to that y. So I go, yep, that is absolutely correct. So what change would I make? Let's look at the first one here if we wanted to compress it by a factor of 1/2. Well, I'm going to cut to the chase. The actual change that you would make is you find the y, and then you put a 2 in front. Now, first you might say, what? That's the opposite of what's going on. And actually, isn't it funny that it seems like so many of the changes that we make, when we do them implicitly, they are the opposite. They are always kind of you do exactly the opposite of what you think it should be. But let me convince you that this is, in fact, the correct change. And we're talking the correct change for this guy, for a vertical compression of 1/2. Let's just see if some of these points are on there. Like, here's one of the points, right? This is the point 4 to the right, and it only goes up 1. Let's see if that actually works in this new transformed little equation here. So that would mean x is 4, and then my y value is 1. Is this giving us a true statement? 2 equals the square root of 4, which is true? Yes, it does. So it's actually quite true. That's exactly the right change that we want. Be warned, often they write these things explicitly, so they might have taken the 2 and divided it over to the other side and wrote it this way. They might have written it as 1/2 times the square root of x. Okay? Now, let's see how much time. Oh, we got enough time to just finish this, and then we'll just stop that. What about a vertical expansion by a factor of 2? Well, again, it's vertical, so we're going to affect the y. Okay. I'm going to leave the rest of the function alone. Now, I would like it to be expanded by a factor of 2. So don't put a 2 here, do the opposite. And that means the reciprocal. Yes, you heard correctly. Reciprocal. That's how you kind of do the opposite with these stretches and compressions. Now, we could plug in a point, but I think I'll just leave it like that. The only other thing I'm going to do is we might see it written explicitly, which means I would multiply both sides by 2. And so you sometimes see it written like that. So this is or this way. Okay, and that would cause a vertical expansion by a factor of 2. But yes, it's the reciprocal of the number in front of the x or the y. In other words, here's the rule. And we're talking about vertical compressions or expansions. Okay, whatever number you have in front of y is going to cause that effect. And then over here, of course, we have our function. And the effect is, it's the reciprocal of that number. So if this number turns out to be a fraction that's less than 1, well, then it's going to be compression. Sometimes it turns out that this results in a whole number, in which case it's going to be an expansion or a stretch. That's probably a good place to stop. Obviously, the x's are going to work very much the same way. And I'm going to come back and we're going to do some examples of these stretches and compressions. So we'll see you in a bit.